This video that's going to test the validity of the following argument. If I will study discrete mathematics, then I will study computer engineering. If I will study evolution, then I will study biology. I will not study computer engineering, or I will not study biology. Therefore, I will not study discrete math, or I will not study evolution. So let's first come up with the variables. Say discrete math will stand for D. Then I will study computer engineering, C. I will study evolution, say E. And I will study biology, B. I will not study computer engineering, so that's not of C. I will not study biology, not of B. Therefore, I will not study discrete math, or I will not study evolution. So to come up with the logical expression, we have, if I will study discrete math, then I will study computer engineering. So D implying C. Then I will study computer engineering. If I will study evolution, implies I will study biology. I will not study computer engineering, so not of C, or I will not study biology, so not of B. So therefore, the conclusion is I will not study discrete math, or I will not study evolution. So we have now our premises and the conclusion. So premise 1, premise 2, and premise 3. One solution for this is to analyze the cases of premise 3. So this is a disjunction, so it is composed of two cases. You have the NAT of C and then the NAT of B. So firstly, we're going to assume first case, which is the NAT of C. Then we could come up with a modus tollens with premise 1, D implying C. And by modus tollens, we could have the NAT of D. And in that case, with addition, we could simply add NAT of E. For the second case, we could assume the NAT of B. And in a similar manner, it could be partnered with premise 1 or premise 2 in this case. So premise 2E implying B, giving us the NAT of E. And again, by another addition, so we have or NAT of D. By proof, by cases, we can conclude with the two cases that the argument is valid. Another solution perhaps will be to utilize resolution between these arguments. So if we could rewrite the arguments, we have D implying C, and we have E implying biology, and NAT of C or NAT of B. Therefore, you have NAT of D or NAT of E. So the equivalence for this, using the logical equivalence, For the implication, we have not of D or C. The second one is not of E or B. So applying the commutative for premise 2, we'll have B or not of E, partnering it with the commutative of premise 3, which will be the not of B or the not of C. So we could have the resolution, and this resolution will give us the not of E or the not of C. So after this, we could partner the this one with the commutative of the first premise, which is C or not of D, and we could also get the commutative of this, not of C or not of E, and finally partner the two. So commutative of premise 1, C, this one, so C or D, not of D, and partner it with not of C or not of E. And by resolution, this will be result to not of D or the not of E. Therefore, by this method, twice applying resolution twice, we get the conclusion. Hence, the argument is valid.